Hello everyone, it is hot today. We are in front of my wife's shop and this is a glacial erratic. Now, the cool thing about this is the texture. Obviously, some of you can probably tell right off the bat, this is a granitoid. It's igneous, it is phaneritic, plutonic, whatever you want to call it. Now, a lot of times people call rocks like this a pegmatite, but that's not really a rock type, it's a texture. It's bigger than coarse crystalline rock, which is. The crystals in this are huge. Where you put that line is up for debate, but basically if the crystals are not only visible to the naked eye, but most of them are easily identifiable with the naked eye, you have a pegmatite. Now you come here and you look at some of this. We'll get to the glittery stuff here in a minute, but I want to show you this. The opaque, lightish pink stuff here. This is K-spar, and I would say the crystals are almost euhedral, subhedral, somewhere in there. Euhedral's really well developed, subhedral's okay, and then anhedral's poorly developed. And you look at it and you can see there's no striations. That tells you it's K-spar. K-spar does not twin readily, so you don't get striations, unlike here where you have striations. So this is plagioclase, and you can see they're similar colors. Now, I don't know what plagioclase this is, but it's probably albite, since we have a lot of nearly euhedral K-spars too. So this, if you look at it overall, there's not a lot of plagioclase in this overall, which tells me the melt probably wasn't very high temperature. K-spars on Bones reaction series crystallize out of a magma near the end of the plagioclase, at the end of the discontinuous series, and at the end of the continuous series. They crystallize less. And you look at the shiny stuff in here that you probably can see everywhere, and that is a mica, but specifically muscovite, okay? And it's, how do I know that? Well, it's light in color. And muscovite crystallizes out right before quartz. And the muscovite's anhedral, subhedral, and the real close, like this semi-transparent stuff, semi-opaque, translucent, is quartz, and it's poorly developed crystal. The quartz is the last thing to crystallize out of a magma. But then you see this right here, and I love this. This is nice, well-developed plagioclase crystals. It's actually a couple of them. Here we have the twinning this way, and then you can see it kind of changes a little bit. This, my guess is this is albite, definitely albite. And it has some later quartz in it, which probably is just an artifact of the space in the crystals. And you have some more here, and you got some more quartz. So this rock, and you got big plagioclase over here, and you've got really big, I mean, you can probably see it from there. I mean, you've got big striations here. So this rock overall is probably mostly right here, it's plagioclase. Over here, it's plagioclase. Now, the plagioclase tends to be more developed here, bigger, telling me, you know, it crystallized a lot longer, had a lot of time. The chemistry was right, the temperature was right to let these things grow. And then your K-spars. I would actually probably call this is a granite, but barely. And you can see the quartz, there wasn't a lot to make quartz out of. It's actually pretty small. So it would be a little less than a granite, maybe I want to say, you know, I wouldn't call it a granodiorite, but it might be. I would have to actually look at percentages. But I just wanted you to see this, and I wanted you to see how you can just look at this and how you can basically tell what the rocks. We don't have any mafics in here. We have some right here, which I can scratch with my fingernail, which is biotite. We don't have any pyroxenes, we don't have any other amphiboles, we don't have any olivines. So this was a low temperature melt that stayed at that temperature for a long time. But anyway, that's it. If you have any questions or comments, please leave below, and I hope you learned something.